Hello and welcome to Noel's RetroLab. This may look like a normal intro to you, but it's not. I am from the future, and I'm coming here to warn you about the repair for this Commodore 64 that you're about to watch, and I just finished. And it's going to get ugly, really ugly. If you're looking for something that involves cleverly figuring out the faults based on observable data, cleanly replacing the parts, and easily verifying the results, go look elsewhere. What you're about to watch may be disturbing to some people, so watch at your own peril. You've been warned. Alright, it's been a while since I've done any kind of repairs on a Commodore 64, but it should be really fun getting back into it. So let's give this a try. This is from my friend Javi's, and I think this is not working. The LED is missing, so before we even power it on, let's open it up and look at it, and then we'll power it on and measure voltages. So this is a 25407 assembly. I think that's one of the earlier ones, so it probably has the more complicated clock system here. Right. This is not the simplified version of the clock system. Everything looks pretty straightforward. Things are socketed, which is good. So I'm going to remove this annoying RF shield. I usually just not keep those. And then let's power it on and see what happens. Okay, let's power it on and see what we get and whether this no signal message goes away or not. We seem to get nothing and we get no signal. That might make it even easier. Okay. So that means that there's something that is really not working at all. So the graphics chip is not generating an image at all. And that's usually because there is either no voltage getting to it, it's completely dead, or there's not clock signal. Those are the most likely options right now. So let's check voltages first. I'm gonna get ground in here. This is the input to this. 17 DC, that's fine. It should output about 12. Yeah, that's good enough. And then, well, that's fine, I'll do the negative. The input to this should be, what, 9? Yep. And output should be 5. Perfect. So these are the DC voltages generated from the 9-volt AC. We also get 5 volts straight into the rest of the system, so I should measure that, for example, at the CPU. Let's slide over, there we go. And that's pin 6. And here we get 4.89. That's 4.9. Yeah, that's probably good enough. Okay, and one last check. I'm going to check the AC voltage right here. That should be, what is it, 9 or, yeah, something like that. 9 AC. Okay, so voltages seem fine. Before we continue, I wanted to thank this video's sponsor, PCBWay. PCBWay makes really high-quality printed circuit boards. Supposedly they call them prototype boards, but really the quality is just as good as any production board I've come across, and certainly way better than a lot of these 80s boards that we see so often. If you're interested in printing your own boards, head over to PCBWay.com and check them out. So as usual, let's start checking the clock signal on the CPU on pin 1. And it looks like we're getting plenty signal right there. That looks totally fine. That's slightly under 1 megahertz, so that's great. And then in 39 we have clock out, which I think maybe is like the half signal or the inverted clock or something like that, and that also looks totally fine. So at least the CPU is getting a clock signal, which means the VIC-2 is also getting a clock signal because it actually generates the clock signal and sends it over to the CPU. Those were my two most likely candidates for why we're getting no video signal at all. So I should probably just look at the video signal itself coming out of the VIC-2. So we have two signals that we really care about coming out of the VIC-2. One of them is sync and luminance, and that's in 15, and then your color information is in 14. So this is luminance and sync, and that looks fine. for an empty, mostly empty signal. And color. So yeah, that's surprising. That looks like we should be getting a signal, but the TV was not identifying anything. Okay, so this is one of those slightly embarrassing moments where I'm double checking things because it makes no sense. We seem to be getting a perfectly fine video signal out of the VIC-2, even though it looks black, but we're not getting anything here. And then I suddenly had the thought, oh no, are we set up for the right input? So we weren't. We were set up for SCART, and this is a composite input. I told you I hadn't done things with the Commodore 64 in a while, so it even says it here actually. So now we're in the right input, the right source, and let's turn it on. And okay, this makes a lot more sense. So we are getting a signal like we already saw on the oscilloscope. It's just black screen. So the causes for this are going to be different than my original theories. Immediately I'll think PLA, especially because the voltages are fine, is very likely a PLA. It could even be a memory, although those often have some patterns. I could pop out the SID chip just to make sure that it's not interfering with things. Actually, let's do that right now. So the SID chip, that you always need to check this because the PLA and the SID will swap places depending on the revision of the board. We don't need this anymore. And I believe this is the PLA. Let's see, the IC U17, that is the PLA, right? And so this one is the SID. Let's just remove it, just to get rid of one possible thing from going wrong. And let's turn it on. Right, and we get nothing. The PLA is socketed, so we might as well try it before we do anything else, not even this cartridge. It's so likely for that to be the problem. So here I have some PLA replacements that I've used in other videos before. Make sure it's off, yep. And then if this is not it, then we'll continue maybe with the dead test cartridge. Okay, so it wasn't just a bad PLA, although the PLA could be bad until we test it in a different computer. But this is probably the way to go for now. So time for a test. All right, with the dead test cartridge in, we turn it on. It's normal that it's black for a few seconds, but after about maybe 10 seconds at most, it should get us some information on the screen. And if not, is that there is something more serious than just some RAM, or it could be a catastrophic failure of a RAM that is interfering with the bus as well. That's another possibility. Suppose I should take out the ROMs as well. Yeah, this is not coming back. So let's take out the ROMs since they're socketed. We don't need any of them for the test. And they often go bad, as we've seen in past videos. Oh, we get a white screen this time. Doesn't mean we're gonna get some cartridge output. Doesn't seem to be the case. But that's interesting. I hadn't seen the sort of gray output before. Does it happen consistently? I'm gonna turn it off and on again. It's not consistent. Interesting. Oh, okay, this is very good. So it looks like we're probably having some memory issues. The test is trying to do things. I don't know if it's going to even be able to identify which of them is wrong. This looks like maybe some kind of video memory is wrong. I'm not even sure it's making any progress. It seems to be stuck in this loop. This probably means it's a memory problem right now, maybe in addition to the PLA and maybe in addition to the ROM. So once we fix this, we can try adding the other chips in. I tried turning this on and off a few more times and I didn't get any output. So I think that something is really clobbering probably the data bus, potentially the address bus. So let's have a look at them. Maybe we'll be lucky and we'll find out that one of the data chips is holding data out always at ground or always high or something like that. So let's check them out. That looks really bad. Because that's not even, I mean, that's just noise. Those are not very fast clock signals. That's just really loud, spiky noise. So yeah, that looks really bad. I'm surprised that anything loaded whatsoever. Oh, and then what is that? So that's mostly high. I mean, that's more believable. Although I would expect the output not to be high so long. Very similar, okay. And then this, oh, this is not just noise. So yeah, it's just generally ugly. Same with that. So was that noise? Yeah, this is noise, but those are not. Those are something. And that is noise. The problem with this is that we don't know where that's coming from. Is it coming from the RAM IC? Is it coming from really anything else connected to the data bus? What about the address bus itself? Let's look at it on the CPU because that's the easiest. Always high, that's not a good start. Okay, that's general activity. That's fine. And then suddenly one of them high like that. Yeah, that's not good. So I'm not seeing any single RAM IC that I'm pointing to it and saying that is most likely faulty. So as I'm looking at the board, something happened and then suddenly I stopped seeing signals. So I start tracing it back and I notice there's no clock signal. I'm like, what's going on? And then I notice that I'm having problems with the voltage generated by these two, well, in particular this voltage regulator, and the VIC is not getting any power. So let's see what's going on. That it's probably an unrelated problem to what we were having earlier. So let's see. I'm gonna turn it on. So that seems okay. 5 volts. Yeah, and this 21. I mean, this is great. So I don't know why it dropped to nothing. I checked the power supply and the power supply is fine. I even tried a different power supply and it's also fine. I even have one of those guard things. It's not on right now, but it's just checking that you're getting 9 voltage AC and 5 volts. And yeah, all of that is fine. But for some reason, the power here just went away, which is not good. Let's try it again. Oh, what? What is this? Look at that. That's, yeah, so I turn it off and on and we're getting nothing there. And we're getting 2. And what about the AC input? We're supposed to get not, so that's fine. But we are getting, oh, now we're getting something. This is crazy. A second ago, we're getting nothing. Now we're getting, so this is even higher than it was a second ago. So there is definitely something weird going on in here. I could try swapping the voltage regulator. It's a relatively easy thing to do. They do fail sometimes. I'm not 100% convinced this is the problem, because I've seen that typically when they get overloaded and you need to leave them 20, 30 seconds, especially without a heat sink, and they shut down. But I guess if it's faulty, the shutdown part could come in and they could fail like that. It's the best theory that I have right now. I mean, I don't think there's going to be any of the capacitors along the way that could be causing this, or the coil, and there isn't much else. So, the other interesting thing would be, does that happen with this removed? So before we even put another one in, just to isolate what's upstream from this. So yeah, let's remove this and turn it on and see if we get a reliable, what was it supposed to be getting, like 9 or 10 volts in here. With the voltage regulator removed, let's check what the voltage is at the input. And yeah, it's still really low, 1.3 and dropping. Okay, so I suspect that it's not that voltage regulator. It didn't really behave like a fault in there, but it's just one of the few things that was in the way. So there's that. There's this other voltage regulator, the 12 volt one, that usually even has a much lower current draw. So I doubt that's the problem. I removed the 12 volt voltage regulator because really there wasn't much else to try in here. And let's see if it made a difference. No, we're still almost no voltage there. And what about the input to... Interesting. So the input to the 12 volt regulator is perfect. It's a 21 volt, and obviously this is a little higher because we're not drawing any current from there. But the 5 volt one is abysmal. Let's look at the difference between the two circuits.
The Commodore 64 power supply provides two different kinds of voltages, 5 volts DC on one side and 9 volts AC on the other. We're having issues with the 9 volts AC, so let's focus on that side. After it goes through some capacitors and coils, the 9 volts AC goes through a fuse on one side and the switch on the other. And then immediately after that, the parts of the system that need 9 volts AC tap into that, and that will be mostly the expansion slot, I think. Following that, we have one path that goes to the 7805 voltage regulator to generate 5 volts DC, and another one that goes to the 7812 to generate 12 volts DC. Both of these voltages are used in the VIC-2 and SID chips. I imagine it's designed this way to avoid noise crossover between this part of the circuit, which is probably quite sensitive to noise, and the rest of the system. So that way they're completely isolated. The 5 volts part of the circuit, which is the one that we're having so much trouble with, starts with a bridge rectifier that converts the AC voltage into a DC one, probably around 8 or 9 volts DC, and then it goes straight into the voltage regulator. So maybe that's where the problem is.
This is a rectifier. Normally you may see those with like 4 diodes, but this has pretty much like the 4 diodes built in. I'm inclined to think that somehow this randomly failed us in the middle of the repair. And by replacing it, we may be able to get our power back. It's easy enough to test. I don't have any spare ones, so I'll have to take it from a different Commodore 64 board, but that's not a problem. I'll go ahead and order some spare ones. It's probably a good thing to have on hand anyway. Okay, the rectifier is out of the board, and let's see if that makes any difference. I'll check that and that. Well, that should be nothing, right? Because nothing gets to here. So I guess I can check the input of that one. That one is still fine. And I can check the AC, which was dropping earlier. So this should be about 9 or 10. Yeah. So that seems reasonable. So maybe it was the rectifier after all. So this was actually pretty difficult to remove from the board. It has really thick legs, and I'm not looking forward to doing that with another Commodore 64. So I would rather check to see if I can at least make sure that this is not working. And so a rectifier pretty much is just 4 diodes arranged in a particular configuration. So here we have plus and minus, that's the output. And then the other 2 pins are the AC current. So we should have, if I flip this, so we have plus minus in the inputs, And we should have diodes that are pointing from here to here, from here to here, and then from here to here, from here to here. And we could at least test that those diodes are working that way and the current is not going the other way around. So let's do that really quickly. So I'll set the multimeter to diode testing, and just to double check, this is the positive, this is the negative. That's good. That's good. That's good. That's good. And then the other way around, we shouldn't get anything. Nothing. 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 So on paper, this looks fine. It may start failing once you actually apply some current. That's certainly possible. So there's something weird going on because I'm testing things and voltages seem to come in and out, and I unplug things and I'm getting different results. So I'm thinking maybe it's something, just not even one of those components. So I've hooked up the oscilloscope to the input of the voltage regulator. This is should be getting like 10, 12. And so, yeah. So I've turned it on and we get nothing. And so I'm just wondering, is there something else going on? Like this has a fair amount of play. This is the AC voltage, or half of the AC voltage, coming through the switch. And does something change as I move this? I mean, it seems to move a little bit in response to me pushing it, and it really moves a lot, the connector. So I suppose we could have some dry solder joints, but I didn't see anything earlier. So let's look at them a little bit more closely, because I can't make any sense of why we wouldn't be getting the full voltage otherwise. So these are the solder joints underneath the power connector, and I mean, they look okay, but it definitely has a lot of play, or some play anyway. And looking at it closely, maybe they're moving a little bit. So let's have a closer look with the microscope. So look at that. That is a crack, that's a crack, and that's a crack. Those are definitely bad joints. They're called dry joints or cold solder joints. And if I move it, oh, look at that, look at that. I'm barely touching it, and you can definitely see how it's moving. Oh yeah, look at that. So this is really amazing that on the microscope it's very obvious, but when I was looking at it on the board, they looked okay. They looked shiny, and yeah, look at that. Like how I can make them wiggle. So yeah, we definitely need to reflow those, and hopefully that's the full source of our problems, and then we'll have power again. So to fix this, I will just melt the solder around the joint and then add some extra fresh solder. And I'll do that with all of them. Definitely with the 3 that were wiggling, but I'll do it with the other ones in the connector as well. Oh yeah, now it's not moving at all. So that was probably it. All right, let's test it again and see if it makes a difference. Look at that. That's the input voltage into the voltage regulator. First try. And this one over here looks fine. I mean, the shape is a little weird, but that's totally fine. So yeah, and I'm sure we get 5 volts. Yep, that's our 5 volts exactly. And 12 volts over there. So wow, all of this digging, and really was the power connector. So really the lesson to be learned here is that on Commodores, if this wiggles at all, look at it very, very carefully, even with magnifying tools, because chances are some of those, there could be some dry joints and you may not even be able to see it with the naked eye. All right, now that we finished all that weirdness with the power connector, we can go back to the problem we were trying to diagnose and see what's going on with the main board. At least now we're not going to get any weird interference and power cutting in and out like we're getting before, and we can focus on the problem itself.
If you enjoyed this video, please consider supporting Noel's Retro Lab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.